Today we're covering 7th grade, Chapter 6, Lesson 1, Identify Linear Relationships. And this can be found in textbook page 441 if you picked up a textbook. The linear relationship is just like that. It sounds like line. It's because the equation, when graphed, comes out to be a straight line. So the graph of the equation is a straight line. And it's a straight line because it has a constant rate. So we can look at just a table, for example, number 1 there, and see if the rate is the same on each side. If it is, then we know that it's linear. And there's a couple of different ways to check on a table to see if it's linear. Let's just take the easy way first and see what the x's are counting by. So each time the x increases by 2. And we have to check each interval to make sure it is actually increasing by 2. Each one of them went by 2. Now, the y's, they are decreasing, so that's a minus. And 50 minus 35 would be 15, so it decreased by 15. And the next interval also decreased by 15. And the next interval also decreased by 15. Okay, notice that this side over here is not the same as this side over here. That's not what we're looking for. We're looking to see, is this number the same each time? And is this number here on the y side the same each time? If they are, then it is considered linear. So this one is a linear relationship because as x increased by 2, y decreased 15 each time. So the rate of change is constant. So the relationship is linear. Let's check example 2. Again, we want to check the x's and see it's increasing by 3. And then from 4 to 7, it increased by 3 again. And from 7 to 10, it increased by 3. It looks like the y's are also increasing this time. So from 1 to 16, that's plus 15. From 49 to 16, though, that's increasing by 33. It got bigger, so it's still increasing. And the next one's increasing by 51. So even though this side was the same each time, the y side was not the same. As x increased by 3, y increases by a greater amount each time. The rate of change is not constant. So the relationship is not linear. And let's go ahead and see what this one looks like on the graph. If I plot the points, 1, 1 would be somewhere around here, real close to the line. And then the next one would go over 4 and up to 16. That's somewhere around here. And then over 7 and up to 49. And then over to the right 10 and up to 100. And it doesn't make a straight line, it makes kind of a curve. So you can always check your work on a graph. Remember, to be linear relationships, the points have to lie on a straight line. If you put the edge of a paper down, the dots would line up with the edge of the paper. It has to be straight. Now let's determine whether the relationship in each table represents a linear relationship. This time let's just try to put them on the graph. So I'm going to go over to the right 0 and up 20 and put a dot. And then I'm going to go to the right 5 and up to 16. And then to the right 10 and up to 12. And to the right 15 and up to 8. And as you can see, those are on a straight line. So that is linear. Again, you can check to see if it increased the same amount each time. So each time that was in, the x's were increasing by 5 and the y's are decreasing by 4. Okay, let's look at example B. That's 0, 0. That's our origin. That means it's over here in the corner. And then we're going to go to the right 2 and up 2 and put a dot over 4 and up to 8. To the right 6 and up to 18. And again, if I tried to connect that dot and that dot, it wouldn't make a straight line. It kind of curves. But we can also check to see this is increasing by 2, this one's increasing by 2, and this one's increasing by 2. So the x's are increasing by the same amount, but y increased by 2, and then the next time it increased by 6, and the next time by 10. So that did not increase by the same amount. They have to be the same, and this has to be the same. Let's look at some examples similar to what you're going to be doing by yourself. You're going to be given two tables, and you're going to decide if it's linear or not linear. And you can do that by checking to see if the rate is constant. So first, let's check the x's. And it's increasing because it's getting bigger each time. -8 is bigger than -10. Remember, negative numbers kind of go backwards. So this is increasing by 2, and this one increased by 2, and this one increased by 2. So the x's have a constant. Let's see if the y's are also constant. This is also increasing, so this increased by 3, and this increased by 3, and this increased by 3. So both the x and the y were constant. If they're both constant, then it is linear. Okay, let's look at example 2 here. Again, we check the x's. That increased by 1, and that one increased by 1, and that increased by 1. So the x's are all increasing by the same amount. The y, from 1 to 5, that increased by 4. But from 5 to 13, that's increasing by 8. And then from 13 to 25, that's increasing by 12. Those are not the same. So even though the x's are constant, the y's are not. So that's not linear. Let's look at one more extra example. There are 24 hours in one day. The total number of hours is a relationship of the days. Complete the table and use the graph of the ordered pairs to determine if the relationship between the days and hours is a linear relationship. Okay, so it already started. 1 day is 24 hours. 2 days would be 48 hours. And 3 days would be 72 hours. And 4 days would be 96 hours. And you can even look at the graph that they gave you. They put each one of those points on there for you. And remember, it has to make a straight line. So if it makes a straight line, then it is linear. And it's making a straight line because the rate is constant.